The turkey in example 1 is removed from the oven when its temperature reaches 185 degrees Fahrenheit and is placed on a table in a room where the temperature is 75 degrees Fahrenheit. After 10 minutes, the temperature of the turkey is 172 degrees Fahrenheit, and after 20 minutes, it is 160 degrees Fahrenheit. You want to use a linear approximation to predict the temperature of the turkey after a half an hour. Do you think your prediction is an overestimate or an underestimate, and then why? So after a half an hour means that would be in 30 minutes. Okay, so first, we know that the formula for the linear approximation is given by the following. L of t, which is going to equal t of the value of a, plus t prime of a times t minus a. Okay, so now what we want to do is we want to let a equal 10, since that's 10 minutes. So a is going to equal 10 minutes, and then b is going to equal 20 minutes. So now, using the above formula, let's go ahead and do that. We know that the above formula is going to be L of t, which is equal to t of 10 plus t prime of 10 times t minus 10. So what we want to do is we want to find out what is t prime of 10. So in order to do that, we need to find the slope of the given values. So we know that from the given information, we know that t of 10, after 10 minutes, we know that the temperature is 172 degrees Fahrenheit. And we know that t of 20 is equal to 160 degrees Fahrenheit. So now what we're going to do is we're going to find the slope. Okay, so what we're looking for is we're looking for t prime of t. So we're looking for the slope. So what's the formula for t prime of t? Well, we know that t prime of t is going to equal t of 20 minus t of 10 all over 20 minus 10. So if we plug that in, we have 160 minus 172 all over 20 minus 10, which is 10, which gives us negative 12 over 10. And so therefore we can say that the slope t prime of t is going to equal negative 1.2. So now what we want to do is we want to be able to plug all that information into our formula. And that formula is in number 3. So using number 3 formula, we know that L of t is going to equal t of 10. We know t of 10 is what? Well, t of 10 is 172. And then plus, we know t prime of 10 is negative 1.2 times t minus 10. So now we're going to distribute. So we get L of t, which is going to equal 172 minus 1.2t plus 12. So the linearization formula L of t is going to equal negative 1.2t plus 184. So now what we want to do is we want to find out, okay, what is the temperature after a half an hour? So we want to find out what is the temperature after 30 minutes. So that means we're going to let T equal 30, and we're going to plug it into our formula. So we have L of 30 is going to equal negative 1.2 T, or in this case, negative 1.2 times 30 plus 184. So we get negative 36 plus 184. And so therefore, we're going to get 148. So L of 30 is going to equal 148. So the temperature after a half an hour is 148 degrees Fahrenheit. Okay, now the next part asks us to find, okay, do you think your prediction is an overestimate or an underestimate, and why? Well, if we had this on a graph, so let's take a look here. We would expect the temperature of the turkey to get closer to 75 degrees as time increases. Since the temperature decreased 13 degrees in the first 10 minutes, 12 degrees in the second 10 minutes, and we can assume that the slopes of the tangent line are increasing through negative values, which is negative 1.3, negative 1.2. Hence, the tangent lines are under the curve, and 148 degrees is considered an underestimate. And from the figure, we estimate the slope of the tangent line at t is equal to 20 for the following. We would say that that would be 184 minus 147 over 0 minus 30, which would then equal negative 37 over 30. And so that linearization would become the following for the estimate. T of 30 would be approximately T of 20 plus T prime of 20 times 10 would give us approximately the following. 160 minus 37 over 30 times 10, which gives us approximately 147 2/3, which we can write as 147.7.